Hello everyone, this is another video from Siemens PLC programming series, and today we are going to implement the ladder logic that able to turn the motor in clockwise, counterclockwise, or in the forward and reverse direction. So if you didn't watch our previous video, please click on the link that you have in the top of the screen, so you actually get to the auxiliary contact video. In that video, we explain about the auxiliary contacts and their application. So which is one of the applications is run the motor in reverse and forward direction. Today we want to implement that and simulate that in the TIA portal and see how it works. So I'm going to implement exactly the same ladder logic that you see here. So for saving time, I'm not go to show you how you could make a new project. I already did in the previous videos, and you already know how you could make the new project and save it on your PC and also implement any ladder logic. So as you could see here, I have exactly the same thing that we had in previous video, and I put these on the online mode run. So that means currently this is a live stream and we exactly could see what's going on here. So just summarize the ladder logic. So see, we are going to add 3 switch. So switch 0 on the PLC-IO 0 is the switch which we call that forward. With pushing that switch, it should be move the motor forward. The second input or second switch that we have is reverse, so I actually put that in IO1. So also we have the stop push button, so which is I put that inside the IO2, so the input 2. So input 0 is forward, so input 1 is reverse, and input 2 is stop button. So if I show you here, so which is what we have, so these actually 3 inputs that I have here. So the first one, this guy, should be actually the forward. The second IO1 should be reverse, and the third one should be stop. Okay. So go check the rest of the logic that we have. So I actually have 2 coil here, 2 conductors. So the coil of the first conductor is M1, the coil of the second conductor is M2. So here, this is the auxiliary contact of the M2, which is here, and this one is the auxiliary contact of M1, which is normally closed. So for now, let I just turn this off, go offline mode. Okay. So here you see 2 normally open conductor, which is controlled by M1. So that means whenever you power on this coil M1, so you technically close this because these are normally open. So whenever you power on these M2, these control this, technically you close this. So I explained in that video, I somehow summarized that. So we have the stop button, so which is normally closed. So that means if you don't push the stop button, you have the power here. So then this is actually normally open. So that means if you push the forward push button, so somehow power pass through this. This is normally open, but whenever you push that button, forward button, you have a power here. So in the beginning, M2 is off, so definitely this should be closed, right? This is normally closed, but because these M2 is off for now, so this should be closed. This is normally closed. No, actually M2 is off. No power in its coil, so it is actually closed. So that means you push the button, power comes here, and able to turn on your first coil. So which is the first coil just turn the motor in forward direction. So because this is on, whenever this is on, this control these normally open conductors. So that means if this is on, this should be closed. So that means even if you release the forward button, the power pass through these paths that you see, and still this is on. This is what we could see from this one. So let's just see, is it really happen in the PLC or not? So I go to the online mode. So just focus first for this one. So let I put everything on 0. So everything right now is 0. So if I could bring these here, and you just focus on this in the same time, okay? So just watch this one, which I put these red circle here. So this is actually the IO0. Even from these indicator, you see this is 0, 1, 2. So this, and the output, this is the 0, and this is 1. So just one things, M1 actually is in output 0, and these M2 is in output 2. This is 0, 1, this is 0.0. So let's check this. So what you expect from this logic, you say, okay, so the stop is the third one. If stop is normally closed, so that means it should be 0, means it's normally closed. There is no power there, so we should close. So even if I change this third one, you see right now it is on and this is off. It changed to the green, okay? So the stop is 0, so that means it's closed. So now the first one is the forward. If I power up the forward, or if I give 1, this should be turned on. So this is also on because this M2 is off, and they should be able to on. So see, I'm just turn on these forward and see what's happened. So see, it is actually on. So even see right now I'm turning that off, but as you could see, still these M1 is on, okay? So again, if I turn on, it is on. So if I turn off, this is still on. So the only way that you could turn this off, you need to actually somehow active these stop for a short time. So right now I active this stop and put that back. See, this is off. So again, if you push the forward, it's actually turn on the motor in the forward direction, and even if you turn off the forward, still it's actually is on. So now let's take a look at this. This is actually the reverse. So that means the second input is the reverse, the second push button, which is connected to the I1 input 1. So definitely what you expect, this is right now, it is in the forward. What I should do? So I should actually stop this. So which I push the stop for a short time. So as you can see, this one is off. So, but this is not on. Whenever it is on, that you actually push the forward or active this, so that's able to get the power here. M1 is off. This should be closed and easily could be energized. That. So this is related to the M2 control this. So that means this would be closed. So that means if you even turn off the reverse, still this is on. So let's do that. So I put the stop is close, and the second one is reverse. So see, now I'm turning that on, so it's actually on turn on the M2, and even I'll turn off the reverse. So see, M2 still is on, so that means it's actually turned reverse. So no matter I push that or not push that, the only way still I could stop to turning reverse is to just active these stop button, okay? So let's do that again. So I put these stop on the 0. So right now all of them 0. So let's see. Just let's do all of them very fast, and at the same time just watch what's happened here. So the IO0 is forward. So IO1, the second toggle switch that I have is reverse, and the third toggle switch is stop push button. So what you expect is really if these two should be able to turn the contactor forward, reverse, and this is stop. So see, if I go to the forward, just I need to push forward button. So I'm doing that. M1 is active. So right now it's turning forward. So even if I turn this off, it's actually it's turning forward. So for stopping that, I'm just push the stop for a short time. It is stop. So right now, if I want to turn reverse, I just need to push the reverse button. So I'm doing that. So see, that's actually is moving reverse. So even if I release the button, still it's actually is in the reverse. If I want to go forward, still I first should stop it. So then I could actually move forward. So I'm doing that fast. So see, right now is in the forward. I push the stop to stop it. So stop. So right now I push the reverse and I'm able to turn that in reverse direction. So as you can see, the logic works, and easily we could have a two push button and easily to move the motor forward and backward. Thank you for watching this video.